And I'll quickly make sure that we live. Sometimes there's like a 30-second delay, and I'm watching myself cautiously. Why is it not going live? What's going on here?
Yeah, and I don't know if I'm able to see if people are in or not. Like with Zoom, you can kind of tell, like, okay, people are there. Here, I have no idea. So it could just be me talking with you for the next hour or so.
Awesome. I'm still trying to make sure we're live everywhere. I believe we're live on YouTube, so I'll quickly introduce Wade and the session. Hey, everybody, welcome to the learning group. Hey, Mateo, thanks for joining us. We are back with another session. Thanks for the constant request. So I convinced Wade to have chai with me again and teach us more about Hugging Face and fastai. Wade is the real host again, and I'll just be keeping an eye out for all of the questions. With that, I'll hand it over to Wade and remind everyone, please keep the questions coming. We'll be actively monitoring the chat and taking any questions throughout the duration.
Great. Thanks, Anyam, for having me back. You didn't have to wrestle me that hard. I was looking forward to getting back, and it feels like forever since we did part one. So I'm glad to be back, and I can't see anybody else out there, but I'm glad to be with you all again. I'm going to share my screen here real quick. All right, and we're back. So my name is Wade Gilliam from omeow.com, and I led the part one study session that several months back, and it was really fun. And again, what we're doing is looking at the Hugging Face course, but through a fastai lens. And so basically the study group is designed to go through the course, but actually focus more on how fastai developers can harness some of the things that are being discussed in building models with fastai. And so anyways, this is part two, session one. And we're going to be looking at data sets pretty much today. And so one thing you'll notice if you go through the course, and I highly recommend that as we do the study group, if you haven't done the course yet, or even if you have, is to spend the next week going back through it, because the part two content is much more dense than the part one content. So with the part one content, I know I can kind of go through most sessions in a day or two. And with part two, I got into the data sets content, and I was noticing I could go through like one subsection every day. It took me an hour or so to really kind of get into it and play around with the code. And so make sure you go through, because there's a lot of content in the part two, and we're not going to be covering everything. I'm kind of handpicking things that I think will be more applicable to folks doing fastai development. If there's things that I don't cover in the study group that you'd like me to cover in subsequent weeks, let us know on the events website. But so today we're going to be looking at data sets, and in particular, how to load them, how they can be used to perform EDA, how we can use them for data pre-processing. And then also I'm in the process of updating Blur based on some of the things that I've learned in the part two sessions. And so we'll begin looking at some of those changes, and we'll look in particular at some of the pre-processing bits I'm adding in there to the sequence classification pre-processing pipeline. And so we'll actually use data sets to download a model, do some pre-processing, prepare it, and then actually train a sequence classification model. So that's the goal for today. Resources, pretty much the same as last time. The links have changed a little bit. If you have folks that want to register, or you want to discuss what we're doing, check out the study group registration page. We have a fastai Discord. a section specifically for Hugging Face and fastai. The link is right there if you want to join there and ask questions on there. And then here's some resources, again, for fastai. Highly recommend the course. I'm not assuming any level of expertise by the folks here. I have a feeling most people have done some fastai. But if you're new to it, don't worry about it. Easy to get started. And the best place to do that is at the course website. And of course, there's the FAST book, which is available online for free via Jupyter Notebooks. And you can purchase it on Amazon and a bunch of other places. And personally, I like the feel of a real book, since it seems like everything is virtual these days. So highly recommend getting the hard copy. Also, another great resource is Zach Mueller's Walk with fastai. He talks about a lot of things, a lot of the questions you have, or at least I had after going through the course in the FAST book, how to do certain things, how certain things work. He covers really well in there. So make sure to check out that resource. And then for fastai Hugging Face libraries, if folks know of other ones, let me know so I can update the slide. But these are the three that I'm familiar with. And so there's Adapt NLP, which is, again, the work of Zach. Fast Hugs, which Morgan, who's over at Weights and Biases, started. And I forget who's taken that over. I'm not sure if how active these are. But that was kind of one of the first kind of integrations between fastai and Hugging Face. And then there is Blur, which is the project I created and is active. And again, if you go to the GitHub, you'll see that I'm working on a version 2 and adding a bunch of kind of new things in there, and hopefully some improvements that folks will like. And then for ML data science in general, you can check out the Chai Time Data Science podcasts, of course, with a good cup of coffee. And also check out Weights and Biases, and begin actually checking that out for using Weights and Biases for any of your machine learning operations. We'll demo some of those things and how I use it for hyperparam sweeps and things like that during the course of this study group. So let's go ahead and start with data sets. And I wanted to go first to the hub here. Let's see. And I wanted to show you that it's super easy going in there and finding a data set to use here. So depending on what you're doing, you can actually come here to the Hugging Face .co datasets, and you can find datasets to use for just about any task you can imagine. There's a lot here, and it spans well beyond just NLP. So there's folks working with like vision transformers, folks doing speech and audio. And so it's nice here. You could go ahead and type a data set that like Blue, for example. And if you're looking to actually start experimenting with some of the things we're talking about today and building these models, you could go in here and like explore the data set. And I like this. I use this all the time, which is the Use in Dataset Library. And literally, you can just copy this code and into your Jupyter Notebook and get a data set to start training on. So this is where you go, and you probably are most familiar with that. So let's go ahead and now look at some of the like the core tasks that, like, as me as a fastai developer, I want to be able to not just load data sets from the hub, but I also want to be able to work with local data. And so when we actually start getting actually doing like real world work or Kaggle competitions, we might be downloading data. So how can we use those various formats, whether it's a CSV file, a tab delimited TSV or JSON or whatever, how can we actually pull those into a data set so that we can actually use that for model training. So I've ran this just in case my internet goes down, but I'm installing datasets and transformers. And just to kind of get things started, I just copy and pasted that code that I showed you before for Glue. And by calling load dataset, you'll actually get a dataset dictionary. And there's a variety of ways. Check the documentation to get subsets of data. So this particular dataset actually has three, or dataset dictionary has three datasets: a train, validation, and test. But if you look at the documentation, there's also ways to load these and just get the training set, or just get portions of the training, validation, and test set. And so there's all kinds of various options. So check out the datasets documentation if you're interested in exploring that. We'll show some examples of that in just a bit. And also I have one general warning when you're doing experimentation with a subset of data, and why you may not want to just get a subset of like the training set to work with. Once you actually have a datasets object, you can go ahead and access it just like a dictionary and look at specific data sets. And once you pull these up, you'll see that this is the same information as right here. But there's other cool things you can do. You can actually look at the data set here, and you could get information that you typically see on the model card. And so if you're actually using the Hub CLI to pull data sets and look at it, this actually may be helpful in determining whether or not this is a data set that you should use for your given task. I've chosen it just because it's a small data set, so easy to load pretty quickly. Once you have one of these, you typically want to start looking at what's in it, because the data sets are, like I said, they're not uniform in exactly how they look and how the data is included. And so typically what I do is just print out the first or a few examples from one of the data sets. So you can see here we have these features right here, and they're included in a JSON L format. So when you are looking at JSON data, typically it comes in one of two ways, which is kind of standard JSON, where it looks like a bunch of nested dictionaries, or what I notice to be more common is this JSON lines format, where it's a list of dictionaries. And that's what we have here. And then one of the cool things with using a data set from the Datasets Library is that they often include a lot of information you need for your Hugging Face objects, your configuration, your tokenizer, and your model object in this .features property. And so you can see that once we call this, we actually see a little bit more details about the particular attributes of each example in the data set. So we see, like, for sentence 1 and sentence 2, these are strings. And then really helpful is for the label attribute, we actually see it's of class label, and it has 2 classes. And as you know, when we do sequence classification, we have to tell our Hugging Face objects how many labels we're trying to predict. And then it also includes the names of the labels. And so most Hugging Face objects, a little bit different than the fastai data sets, actually include the numerical indices of whatever you're trying to predict. So here we have 2 labels. We're trying to figure out whether 2 sentences are saying the same thing. They're equivalent, not equivalent, but in the data, we only have like 1 or 0. So this is helpful information that we can use in building our data blocks and also doing our training. So when I start, those are basically the things as a fastai developer, try to find a suitable data set for a task I'm working with and explore it, make sure it makes sense. And I understand, especially if I'm doing something like sequence classification or token classification, the number of labels and what they represent. And then from there, we want to load the data. So when we load, most folks are using one of these straight CSV files, JSON data. The .jsonl, which is the JSON lines, which again is a list of individual JSON objects. And then for me, I'm much more comfortable working with pandas. And I typically load everything into pandas because in terms of a library, it's the one I'm most familiar with using to explore the data, but also massage it and do the feature engineering and prepare it for machine learning. And fortunately, the Datasets Library has a lot of integration with pandas that we'll look at in just a little bit. So for working with CSV files, first off, one of the things that's kind of nice with datasets is that it has a very familiar API if you're used to using pandas. So I can actually take this data set, the training and the validation, and call to CSV and actually create a CSV file. In this case, I'm doing it just for demonstration purposes to show how we can load a CSV file using data sets. But if you wanted to actually download a data set from the Hugging Face Hub and store it locally to work on later, this is how you can do it. But here I'm just using it to create a training and validation CSV file. And if I wanted to load that into an arrow format, so take advantage of all the niceties that the Datasets library has, it's as easy as calling load dataset, specifying CSV, and then a CSV file. And then, of course, if you have a training and validation, a test, the data files can be specified as a dictionary, and you could give it whatever name you want. It's probably, I'm changing it up here a little bit, but it's probably better to stick with kind of the naming conventions that most data sets share and use training and validation. But if you do this, you'll notice you'll get a data set dictionary with your train and your validation data set. So really easy to use with CSV files. With JSON files, again, it's a little bit different depending on the format of the JSON you're using. Here, I'm actually going to save the training and validation, but I'm not going to save it as JSON lines. That's the default. And I'm going to save it more like a traditional JSON object, so a nested dictionary. And when you do that, you'll see that, at least with these particular attributes, and we actually pull up the JSON to look at, you can see that it's actually, we have a couple of keys on the JSON object, and our data is in the data key. And we can actually pull this up, and you can see, like in this particular case, it actually, these are essentially JSON L-like files, but they're, again, nested in this data attribute. And when you do that, when you work with JSON files like this, and one of the common ones that I can think of that looks like this is Squad. So if you're using Squad for building a question answering data set, you'll want to explore more on like how to, you'll need to specify this field attribute with where the data is at. And also there's a few other things you have to do to be able to flatten that data to actually build examples that you can use in fastai. So again, with standard JSON, we just have to specify this. We can specify one or more data files, and we're good to go. So with JSON L, again, a little bit more simple. And here we're going to go ahead and save things as JSON lines, which is the default when you use to.json on a dataset object. And you'll see when we actually look at this, it's save these as each example is a dictionary, and it's a single line in this file. And to load it, we don't need to specify that field attribute. We just need to go ahead and pass our data files. And again, we have our dataset dictionary. And then one of the another nicety, there's all kinds of ways to specify data files. So they don't have to even be local resources. They can be remote JSON files or remote CSV files. If you have a bunch of them, you can actually use like the glob syntax here to just pull up all of the JSON L files in a particular directory. You can even specify remote compressed files that are in gzip, tar, or zip, I believe. And it will actually do all the work of decompressing the files and building your data sets. So there's a lot of like really cool options for working for data files. And I encourage you to look at the documentation to see how that all looks and what you can do with it. So these are the core things. And of course, there's also data frames. And I'm going to go ahead and create a data frame, which is as easy as calling two pandas. And you can see that once we have that, now we can work with the data frame and using all the pandas syntax that most of us are familiar with. And assuming we have data frames, we can actually convert them to data sets pretty simply by calling dataset from pandas and passing the data frame. And so you can see that that creates a dataset object for us. And so one of the things I find myself doing is downloading a data set. And when I don't know how to do the pre-processing using the Datasets library, I basically fall back to creating a data frame, adding columns, doing feature engineering, and then bringing those back into dataset objects for actually doing any further pre-processing, just because there's some advantages we'll cover in a little bit to using data sets, and then using that actually in my fastai models. So you can see that pretty easy to go back and forth with pandas. And then as the course talks about, if you pickle data frame, you can actually use that eventually by passing in pandas as the first argument to load data set. And again, you'll get your data set dictionary there. One thing you'll notice as you go back and forth, remember the features property had the information about the labels, the number of labels, and the actual label names. So as you go back and forth, you lose some of that. There's probably ways to add that back in, but just be aware of that. If you call dot features on your training data set, you may not see all the things that you saw before when you just loaded it straight from the hub. So that's how you load a data set. Some tips and tricks is, again, the automatic decompression. Most places, I think even the fastai data sets are remote and compressed. And so it's nice to be able to simply point to a URL with a compressed file and call load data set and have it, again, decompress and bring the data down and create a data set object for you to start working with. And as I mentioned before, data files can point to local or remote files. I think for most of our cases, we're downloading data at some point, and we'll be mostly working with local files. But again, the remote files is really nice for big data sets you can't store on your machine or don't want to keep on your machine, or you're experimenting with data sets in fastai or Hugging Face or anywhere else. And then just a last bit of advice is that for JSON, and this is per the datasets documentation, the most efficient format is the JSON L format. So tend to use that if you're serializing your data locally. Any questions on working with datasets, Sanya?
Quickly scrolling back. This one question: how will we be using fastai through this course, and will we be just using fastai data block or beyond that as well?
So we're going to work through an example in just a few minutes of using a preprocess. So we're going to use the Datasets Library to download a data set, do some preprocessing, and then show you how you can use that preprocessed data to train a transformer model in fastai.
Awesome. There are no other questions. I quickly want to point this out. I was trying to debug this issue. We also requested people to sign up, and there's some server issue on that place. So I'm trying to fight that. But if you're watching the recording, now you know what happened. And right now, the preferred place to ask questions is the YouTube chat. So please ask them there, and I'll keep an eye out.
All right, awesome. All right, thanks, Anya. Okay, so now let's look at some of the things that you're going to want to do when you download data. And for me, I'm a big Hobbit Tolkien fan, so I named this section to Data Frames and Back Again. And this I'm highlighting because I think most folks are familiar with pandas and with working with data frames. And for myself, at least, it's where I tend to go for doing any type of analysis of the data. So trying to understand it, visualize it, and also any really complicated feature engineering. And a lot of that is that I don't really understand everything you can do with data sets. If you look at the documentation, it's pretty amazing. There's a lot of things you can do, and there's a lot of reasons to work with a data set object. And so part of it is just me kind of learning how to do more with the library. And so for what I don't know what to do, I typically fall back to building a data frame. And it's actually really easy. If you pull up a data set object or a data set dictionary and you call set format to pandas, it's not really changing. These are arrow files, and we'll talk about that in just a second, what that is and why they're nice to use. It doesn't change the underlying format of the data set dictionary. It basically just allows us to access it as if it was a data frame. And so you can see that once you call set format, if we go back and pull 3 examples from the training set, that once we pull these, they act like a data frame. So we could call like .head here and actually see the 3 examples. And then we could do cool things. So when you get a data set, one of the things like for sequence classification is you want to look at the labels. And especially if you're experimenting, you want to make sure that you have a good set of all the labels that you're trying to predict. And so you want to do things like be able to call value counts. And it's really easy. Once you have a data frame, you have to use the slicing to get the entire data set as a data frame. Then we could go with the label attribute, call value counts, and ensure that we actually have some labels. And if you recall, I told you there's one thing to be aware of when you're loading a data set, is that there might be a temptation. You can actually construct a load data set call so that you only get a subset of the training set, let's say, which you think that's great for experimentation. The data downloads faster. You're only getting maybe 10% of the examples. But one of the things that happens a lot is that these data sets, the labels are ordered so that if you get a subset of the training set, let's say, you might actually not get all the labels included in your data set. And so I'll show you the way that I create subsets for experimentation, but it's just something to watch out for. These labels are the examples in many cases aren't randomly placed. And so if you get a small subset, you actually may miss some of the labels when doing classification tasks. But yeah, so once you have it, if you want to do this set format and slicing in one line, as I showed earlier, you can just take a dataset object called 2pandas, and you'll get a data frame. And again, what I tend to do, since I'm more comfortable in the data frame world, is I go here to actually do any type of feature engineering. And you can see, just as an example, if I wanted to add a column and then bring this back into a new data set, the new column shows up here. So really nice interchange with pandas and data sets. And then after you're done working with a data set in the pandas format, it's recommended that you call reset format. If you don't, and you're using the dataset map method to do tokenization, you may run into some issues. So just be aware to call reset format once you're done with that. And you might be asking yourself at this point, if you haven't got through the course, why use data sets? And there's actually two really big reasons. And I've hit both of them in my work. And the first is that these are in an arrow format. So these data sets are a memory map file, which means that when you're working with the elements in a data set, you don't have to load them all into memory. And so you have, and also it allows you to do multiprocessing. So if you look at the dataset.map method, you'll see that we can tokenize things in batches really quickly. And it's because of how these data sets are stored. And I've actually had issues where I'm loading a data set and I just run out of RAM. And if you look at the course, they actually show you how to look at how much RAM you're using. And you could play around with loading a data frame and saying how much RAM that's consuming versus a data set. And it's really amazing just how efficient these arrow files are. And again, it's because they're not loading everything into RAM. They're actually just loading it as you need it. And so check out some of the blog posts by Dejan Simics. He has actually a post talking about how the Apache Arrow format works and how it compares to pandas. And for anybody that's loaded big data sets, you'll know how much RAM utilization can skyrocket. And then Wes McKinney has this rule of thumb that you typically need 5 to 10 times as much RAM as the size of your data set. And so that's one of the first reasons to consider using data sets for pre-processing and actually training your models. A second one, especially if you're building language models or just have really just huge data sets for whatever reason, is you can actually stream these data sets. And not all of them are streamable. I don't know if there's an easy way to find out in the hub, but if you add streaming equals true, you'll be able to stream it and you'll access the stream data set, kind of like how you access data loaders by using an iterator. And so check out the documentation and the course. There's actually some examples of not just streaming a single data set, but combining multiple streams. And if you're working with really significantly sized data sets, definitely something to look at. Again, how you access the data and how you pre-process it is a little bit different. So check out the streaming data set section in the course if you're interested in doing that. Any questions on the why of data sets?
There's a general question by Turka. So, is Colab good enough for datasets, or do you need like a special server? Like, do you have a rule of thumb for that? When do you use Colab, and when does that cap out?
So I don't have a good rule of thumb myself. I think if you run out of space, obviously that's a time to explore something else. I typically do a lot of my work in my machine learning work and also my development of Blur. I have a local DL rig, and I do most of my work there because I have like a couple terabytes worth of data, so I can put a lot of data on there to work with locally. It's not the most amazing machine. It's not one of Sanyam's, machines, amazing GPUs and all the RGBs, but and I'm using basically I have like a 1080 Ti that I still train a lot of this stuff on, and it works great. But I think if you're comfortable using Colab, use it until you can't, and that would probably be my advice. And if you're getting really big, then you may want to explore, using some other cloud options or a local DL machine.
Awesome, thanks for that. Yep, this I think this comes from Jeremy, right? He always tells this advice: just use whatever you have until you run out of it, and then figure out that bit. You don't want to be like an IT admin, because like once you have a local rig, half of your job is just to like keep it
Right.
up to whatever
Yeah,
version of the framework is out there.
and I'm going to show you all in a second how to create subsets for experimentation. So that's another kind of best practice with just machine learning in general, is don't waste your time downloading these huge data sets and pre-processing them just to find out you're doing it wrong. It will not be pleasurable. And I see a question about SageMaker Lab. There's actually an
That was the
article.
one I had just asked.
Oh, okay. Yeah, I haven't played with SageMaker Lab yet. There's an article by Benjamin, I forget his last name, and he compared those. Maybe I'll find it and we'll share it on the website. But actually compared his experience using SageMaker Lab with Colab and Colab Pro, and actually using fastai and Blur with Hugging Face. So
Interesting.
I'll find that. We'll see if we can post that somewhere else.
Thank you. I will again email the link to everyone who's watching right now, or we'll just post it on Twitter. Is it necessary to complete part one of the course? It's not necessary. You're welcome to join still.
Yeah.
Um,
We won't kick you out, but it would be helpful probably to get the overview. You sure?
have you tried using Hugging Face datasets with non-language data like time series?
I haven't done anything outside of NLP tasks, and I'm not sure if it supports time series tasks. I know it does with vision and like speech and audio. So the answer is no.
Awesome. I want to share another advice. One thing like I learned the hard way. I'm sure people are smarter than this, but on the rule of thumb of having 5 times the memory of your data set. I remember I was working on this Kaggle competition titled Microsoft Malware. And before I teamed up with like really smart people, I was just using the default pandas options, whatever they were. And this was like a small CSV file of I think like half a GB, and I was running out of swap that was 100 gigs because I wasn't converting them to, I think so by default it's float 64. I wasn't converting them to simple integers, and that was just making the memory explode. So it's
Oh,
also
boy,
helpful to
yeah.
do those conversions.
Yeah, and so that's one of the things I learned really early on with FastAI is that start with small subsets and get all those things out of the way, because I still make all kinds of dumb mistakes because I'm trying to like do tons of things from full stack web to building Blur to doing just other machine learning work. So it's amazing how much I forget. I go back to doing things and I repeat the same dumb stuff, and it's a lot more efficient to repeat the dumb stuff on a small set of data than the whole thing, for sure.
I'll squeeze in another question. Do you have any other tricks for reducing training time, like when you're trying to actively prototype?
Sure. So the biggest one is just working with a subset of data that's fairly representative of the data that you're going to eventually want to really train your model on. There's also some callbacks in FastAI. So there's a callback, and I'm going to get the name wrong, but it's like the short epoch callback. And essentially what you can do is start training an epoch worth of data and just say, hey, only train for 1,000 steps, or only train for 10 steps, or for 5% of the time. And so when I actually build my test in Blur, and I'm trying to make Blur so it works with the majority, if not all, of the transformer NLP models you see on the Hugging Face that's supported by Hugging Face. is I actually use that to iterate and just make sure that, I can go ahead and train these models without having to, wait 30 minutes for some of these bigger models to actually, complete an epoch. So those are my two probably biggest pieces of advice. And again, we're going to look at in just a second is actually how to create a good subset of data to do that.
Awesome. I think that was the last question, so please continue.
Cool. So I just want to highlight, and these slides in the notebook will be made available after today's study session. But I want to highlight some of the things you can do with the Datasets Library. And these are things that I find myself doing all the time. And again, if you look at the documentation, there's just tons of things that you can do without resorting to pandas. And so I just include some examples about working with specific rows in a data set. You can go ahead and grab specific indices if you're renaming and removing columns. And this is a common practice when you look at the course, because when you actually feed things into their trainer API, or you create your own PyTorch loop, and or using their accelerator product, you need to remove columns that you don't want to feed into your model. Whereas with Blur, these things are, you could keep these things in your data sets, and they're simply removed when you actually call the forward method of your model automatically. So some of these things, when you go through the course, you don't need to do a lot of the cleanup with Blur that you have to do if you're using the trainer API or your own PyTorch training loop. So anyways, so it's super easy to rename, remove columns. There's a couple ways to add columns. If you are actually using the map method and you're passing in one example at a time, you can just simply return a dictionary with the new column and whatever you want that to be. If you're working with the data set and just want to add a column, then like one of the things in fastai, which we'll see in a second, is that fastai typically wants your training and validation data in a single data set. And one of the most common ways to do that and indicate what examples should be part of your validation versus your training is to simply add a is valid attribute and set it to true for the training, for the validation set, and false for the training data set. And you can do that with add column, specify a new key, and then here, this is just an example, and this should actually be valid or validation DS. I say true times the length of the data set, and that will create a new attribute in this data set where is valid is set to true. So these are really helpful. For pre-processing, again, a lot of the things that you can do in pandas, you could do more efficiently in data sets because of the arrow format. And here's a few examples of, for example, if you're normalizing your data, need to remove nulls, need to lowercase all your text. This is a helpful one if you need to remove examples that are too small. And so when you're doing a lot of NLP work, if the text you're looking at, so in the course they have, looking at this data set, they have a review length attribute. If it's too small, you may want to get rid of it because there may not be enough helpful information to really use in whatever task you're trying to do. And this is also from the documentation. This is actually a really cool example of removing HTML. So if we import the HTML package and call unescape, we can go ahead and clean up our reviews. And you'll see a lot of data sets have a lot of HTML artifacts in there. And so this is actually a nice little piece of code that I think you'll find helpful. And then another nice thing when you're using data sets is this map method and the ability to pass your examples into a function, but instead of just one at a time, to pass them in batches. And if you play around with setting this true or false, you'll see like it makes a really significant difference in how fast your pre-processing And in particular, things like tokenization are when you set batch equal to true. The only thing to remember is that when you do that, and so again, we're calling map with batch equal true, and that's going to call a function, is that it's not going to pass in an example at a time. It's going to pass in a dictionary. And the dictionary is going to, so by default, it's 1,000 examples at a time. The dictionary is going to have, let's say there's 3 attributes, ID, text, and label. You're going to get a dictionary, and it's going to have those 3 keys. And for each key, it's going to have the values of all 1,000 examples that are passed in there. And so how you access the examples and work with your data is going to be a little bit different when you use batched equals true. And so you can see here, assuming that batched equal true in this example, instead of just setting the value of an example of the review value, we have to actually iterate over all of the review values. So this will be all 1,000 review values for the 1,000 examples that are passed in, and call unescape, and then set review equal to that. So it's a little bit different, but definitely this is the preferred approach when you're doing pre-processing, is to handle them batch fashion as much as possible. So data frames, we already talked about this at length, and so I'm not going to spend too much time on this slide. Just be aware that you can dip in and out of using pandas. And for me, I'm a pandas guy, so I know how to do a lot there. So I typically go down there, and as I read the documentation and find out how to do things in Datasets, I try to do more in Datasets. But just know you can go back and forth. All right, so let's go ahead and look at how to actually use some of this stuff with fastai. And let me reconnect. All right. Okay. So one of the things I mentioned earlier is that I'm actually working on a version 2 upgrade of Blur that's going to break some things. When you are using the Dev 2.0 branch, you can do a pip install in Colab using this syntax, and you just put @ and then your branch name, and this will install the latest build of the version 2 bits. And it's a work in progress, so things may break if you're using it for other tasks. And for folks, if you encounter those things, let me know. If you want to help contribute and work on some of this stuff, let me know. I would love to help. But for the purpose of this study group is install the Blur bits like this. My goal is at the conclusion of the course to have a build that is ready for public release. And then once you install version 2 of Blur, we're going to go ahead and import some of the things that you've probably seen before if you've used Blur to train fastai models. And again, one of the things we talked about is we want to create a subset for experimentation. And so I'm going to go ahead and start with building a simple sequence classification model for IMDb. So we're just looking at movie reviews, they're positive or negative. But we're going to, instead of loading this from the fastai datasets, we're going to go ahead and load this from the Hugging Face hub using load dataset. And for this purpose, I'm just going to pull the training set. So if you look at the documentation, as I mentioned, there's all kinds of ways to configure what subsets you want and how much you want from each subset. For experimentation, I find it nice just to be able to get the training split and work with that until I have something that I know is working. And so we can see that this gives us this particular data set. Notice, because we're getting a specific split, we're not getting a data set dictionary, we're getting a data set object. And from here, we can use this train test split to manufacture a test or validation data set. And it works very similar to how scikit learns method works. So this should be fairly familiar to most folks. But you can see by taking this single data set, I can go ahead and split it into a train and test. And you can specify the ratio of test examples to, or validation examples to train. And then I'm going to simply rename the test set validation, just because that's how I think of these. That's how I think in terms of how the set's going to be used as a validation set, not as a pure test set, which is a holdout set for after you actually have trained your model. And then we can actually use the Datasets library to do some interesting things with it. So one thing, since I mentioned in the fastai world, you typically want to put your training and validation set into a single data set and have some indication of which examples are for validation and which are for train. And you can do that through using indices. You can use that. You can do that also by adding something like I'm doing here, which is a valid attribute. And essentially what I want to do is have it so that if the example is part of the validation set, is valid is true. If it's part of the training set, is valid is false. So I create this little method, and I have two of them here so that you can go back to this notebook and see how you should structure things depending on whether you're going to be using calling this with map and passing a batch of examples, which is this batch friendly one, or if you're passing one example at a time. And I really encourage you to actually explore looking at this, and you'll be able to see the speed difference just visually in terms of how quickly this one worked compared to this one, even for a small, relatively small data set. And so calling map, I'm also using partial, which is part of the functools package. And essentially what you can do with partial, if you haven't seen it before, really common to see this in the fastai code, is you pass the name of your method, and then you could go ahead and specify what the values of the arguments, any ones that you want to change using partial, and it returns the function object, but now is valid is set to false in processing my training, and it's set to true when processing my validation data set. So take a look at that. And you can see that once this runs, it runs really quick since I'm using the batch friendly approach here. And you can see that now I have a new feature called is valid in both my training and validation set. And then I could go ahead and actually pull up an example and see like, okay, there's that is valid attribute, it's false. So everything looks good. So once you have your training and validation data sets good to go, again, you want to be able to work with a subset of data. And this is just to primarily for experimentation, or if you're doing a blog post and you want to demo something to somebody, so that you're not waiting around for hours for things to train, or hours just to find out that you're casting, you're trying to cast a string to a float, and that's not going to work. And so with the Datasets library, some really helpful methods is you can actually shuffle the data for the validation. I don't really need to use that here, but we can shuffle the training set, and I can say, hey, I just want to select the first 1,000 examples of the shuffle data set. For validation, I want to just select the first 200. And if we look at this and we create now another data set object, right, a sample for training and validation, we can see that we have now a smaller subset of the data to experiment with. So this is really essentially the code you want to use when you're experimenting and creating a small sample just to test things out. And again, we then want to take this training and validation set and put it into a single data set for us to feed through our fastai data and training code. And fortunately, with Hugging Face, it's really simple. We can go ahead and use this concatenate data sets pass a list of the data sets that we want to put into a single data set. And you can see that now, so we have 1,000 training examples, 200 validation examples. Now you can see they're all here in this proc_ds. And now that everything's in a single data set, we can actually use it for working with fastai. So one of the changes that I made to Blur is, as I mentioned earlier, is that with these Hugging Face dataset objects or datasets, is that the labels are typically the indexes of the names attribute that we saw. And so when you actually do like show batch and show results, you see 0, 1, 2, 3, whatever. So one of the changes I made in version 2 of Blur is being able to pass the labels so that when you're showing and predicting things from your model, you actually can see the friendly label rather than the unfriendly integer index into the label names. So we're going to pull these up here. So we do classification. We need to be able to tell our Hugging Face configuration and model how many labels it's expected to predict. And so again, we can use this feature attribute on labels and get the names. So here we just have negative or positive. Then I'm going to use Blur. And if you haven't used Blur before, I hope this is pretty straightforward. You can check the documentation. There's examples in the documentation. Other people have actually used Blur and put it in blog posts and probably said things a lot more explanatory than I make them sometimes. But what we can do is use this utility class, this Blur class, and call get Hugging Face objects. And you could pass a bunch of different things to it and get the architecture of the Hugging Face artifact you're creating. So in this case, it would be Roberta, since we're using a checkpoint, this Roberta-based checkpoint. We get a Hugging Face configuration object, tokenizer, and model. And also notice that we're passing in the number of labels, right? Because we're doing sequence classification, we have to tell it how many labels we're trying to predict. And we can print these things out and see, yep, those are exactly the objects that we expected. So how do we use this preprocessed or this process data set from the Datasets library that we just built? So new in version 2 is instead of just working with raw data on the fly, in version 2, you can do the tokenization on the fly as you've done in version 1, but you can also work with preprocessed data sets, which is kind of the more traditional format. And when you go through the course, that's typically the approach that the course takes and that most folks would go through. And that means they're going to actually pre-tokenize everything, create their input IDs and all the other stuff ahead of time, and then pass that into the model without the model having to worry about doing tokenization on the fly. And so you can do either approach. And so in version 2, we have this preprocessor pipeline. And for each task, there's going to be a task-specific preprocessor. And what this is going to do is based on a bunch of things you can pass to each of these preprocessors, and they're different per task. It's going to actually create either a data set or a data frame. So you can call process HF data set or process data frame. And it's going to do the tokenization and whatever else you want done to the text. So you can do things like handle long text by allowing an overflow mapping. So you can create multiple examples and break longer text and the model can handle into chunks. It's going to handle things like that. And so you can see that once we run it through this preprocessor, we actually have our input ideas, which is typically what we have on the fly with Blur 1 as each batch is being processed. And so with this preprocessed data set, we can actually now use this in a data block. And one of the things that we're doing with Blur is, again, passing in that labels that we configured up here so that we have the friendly label names instead of the ones and zeros when we use the fastai show methods. And then also, we can't use the call splitter because we're using a data set, not a data frame. The call splitter allows us to have a data frame with a column named is valid that indicates true or false. But we can use the index splitter. And so this code right here is simply how I'm iterating through the data set, and I'm basically setting anything that is valid equals to true as one of the validation examples. And you can see if we look at that, we have 1,200 examples. The last 200 are our validation set. You can see that is a way for us to verify it's getting the right indices. And so from there, we can actually build a data block. And here I'm using item getter. So remember, we've already pre-processed our data. We've already tokenized it. So we have our input IDs. And I'm going to pass that as our X. Our Y is going to be our label, our index splitter with our validation indexes. There's a lot of options, things you can do with Blur. One of the objects I have is a text blocks, which will basically do just about everything to set up your data loaders in a way to be able to train it with fastai. And I passing in our Hugging Face objects. And then this is a new addition with version 2, is I'm passing in pre-tokenized. And this is going to tell Blur, you don't need to do the tokenization on the fly. We already have the input IDs. You're good to go. And again, I'm passing in labels in my before batch quargs so that I get prettier show methods. Once you have this, we'll go ahead and pass our data set to our data block data loaders to get our data loaders. And you can see that when we call show batch, we don't get ones and zeros over here. We now get the actual name of the index that's included in the raw data. And so you can see that's all it takes really to build our data block and to get our data loaders in a format ready for training. And then to train it, again, this is code straight from the documentation. We will go ahead and wrap our Hugging Face model in this base model wrapper. And this does a lot of the work of ensuring that only the things that the transformer model needs get fed into its forward method. And this, again, is pretty much just straight fastai code. We use a learner, pass our data loaders, our model object, which is our wrapped transformer. What we want to do for optimization, loss function, metrics, I'm just going to do accuracy. There's a necessary callback called a base model callback that knows how to handle the outputs from the transformer models. And then we also have a default splitter. And if you look at the documentation, you can see how that's essentially knows how there's certain ways that most transformer models are set up. And so based on that, we actually split those into different groups for discriminative learning purposes, or discriminative learning rates, I should say. And so it's going to create different parameter groups based on the actual architecture of the model that you're using. And you can see once we have this, we can also convert this to FP16 if we wanted to. But now we have a learner. We can call fit one cycle. We can use discriminative learning rates and train this. And you can see for the subset, we get pretty good results. We can call show results. And actually, again, we're seeing the friendly labels because we included that when we created our data block. And I've cleaned up the blur predict method a bit. And so we can go ahead and pass in a single string or a list of strings in this case and get our predictions. So it shows our labels, the predicted label index, and then it shows the probabilities for the 0 and 1 labels. And so this is basically shows you how you can actually get a data set, create a subset, build your data blocks, and actually train a sequence classification model on that subset. Any questions on all that stuff?
There's one question. Does Blur right now support any NER, named entity recognition capabilities?
Yeah, so these are all in process, and some of the code is really ugly. So don't hate me if you go to it and are just like, oh my gosh, this is horrible. My first go around is to get most of the stuff to work. So token classification. So if you're doing name entity recognition, most of the token classification bits are there. I'm introducing some new ideas that I don't know will be useful to people, but I have a way that I'm splitting large documents up, kind of like how question answering, how you can overflow and create multiple examples. I'm playing around with ways to do that with token classification that ensures words don't get split up. So a word can be uh, tokenized into multiple tokens, and so some of the stuff is just kind of like exploratory at this point, but the token classification bits I think will work. So you can try those out if you're interested. And I've incorporated a lot of the ideas from the course into it. So when you look at the course, there's different ways to aggregate the scores when you do token classification. Those are now supported in Blur. Um, and and then also with some of the inference time, so using the actual token classification models for inference, the results look more like what you would get out of the Hugging Face token classification pipeline. So hopefully that will make more sense to folks. And yeah,
That's awesome. Thanks for sharing that. I also want to point out you've been pointing towards the docs. I think they're quite awesome for even like checking out all of this stuff with like Hugging Face.
yeah,
I think Wade, you've been around the Hugging Face ecosystem long enough, but you would recall they did a nice refactor of their docs website a while ago, and now like it's much easier to look up stuff.
yeah. There's a light mode, dark mode, so they're one of the cool kids on the block. So yeah, there's a lot of stuff, and like I said, the course is really dense. So I really hope, and that's part of the homework I would give to folks is to go through part 5 this next week before we get into tokenization, because there's really a lot more that you can do with the datasets library, and it's almost like I feel like it's it's like Excel is to me. Like I think I could do a lot with Excel, but then when I look at the real masters of Excel, I realize I probably only utilize it like 5%. Like and the datasets library is kind of like that too. And so really a lot of really cool things you can do with that.
Yeah, it's definitely a lot to unpack. Uh, yeah, that was it. I'll hand it back to you.
Yeah. So anyway, so for homework, go back through part 5. If you have already, if you haven't, go through it for your first time and spend some time, taking notes. And each of the pages can be run as a collab. So you can just click a button at the top right, I think, and open up in collab and run the code and look at it. And then also, just real quickly looked at some of the new pre-processing code in Blur. I have a link exactly to where this pre-processing classes that I just showed you for sequence classification is. Check that out. Make sure you can understand it. Maybe even try doing that with something from the datasets or from the dataset hub. Try doing that with the data frame, maybe, and building some sequence classification models. And make sure you understand that. If there's questions or problems, I would love to know about it. And even better, if you submit PRs, then I don't have to do anything. I just have to hit the approve button, assuming that they all work. So yeah, that's the homework I would give. And like I said, this is really a core part of machine learning is being able to get your data. So really spend some time with this. Actually, was one of my favorite parts of the part 2 course was this particular section.
Awesome. Um, I'm checking to see if there are any questions. No, I'll add another suggested homework from my end. We're also hosting the Keras reading group where we're going through the Keras Bible, I would say, deep learning with Python. And we are hosting 27 days of Keras where we're giving out swag to people who submit any blog or any notebook as a way to encourage everyone to, first of all, learn Keras and contribute. Datasets is quite agnostic to both PyTorch and Keras. So That's another suggestion. If you'd like to win some swag and share your work with the community, you can join that train as well.
Yeah, and we'll probably, I guess, we have some competitions in the study group, so more information to follow. But they'll probably be with blog posts, and maybe we'll have a competition data set and see what folks can do in terms of actually getting results using fastai to train a transformer model to do something.
Yeah, last time we did this and we got a lot of positive
Yeah,
feedback, so we'll try to bring it back as well.
cool.
Awesome. Was that the last thing you wanted to share, Wade?
No, that's it. If like I said, we'll get the resources, the Google Slides, and also the um, uh, Jupyter Notebook for folks to play with. And again, I just encourage you to look at the documentation for Blur and look at some of the new bits of code. Outside of looking at documentation, looking at code is typically how I learn how things work and how to work with different libraries. So I just really encourage that. And hopefully it all makes sense to folks.
That's a practical advice, very practical advice to wrap up on. I'd remind everyone to follow Wade on Twitter. As I said, he's the real host. I was trying to fight an issue, and also apologies to everyone. This is my job, making sure that everyone has a good learning experience. I know people signed up and they weren't able to watch the live stream there. I try to make we at Hugging at Weights and Biases try to make this a nice experience for everyone. But sorry about that issue. That won't happen in the future. So if you're watching the recording, sorry about that. Please follow Wade on Twitter. Please sign up for the group. We look forward to seeing you next week. And if you share any blog posts, be sure to tag Wade, me, or Weights and Biases, and we would love to amplify your work. And we would also try to encourage it by sending some swag towards the submissions or the person's way. So thanks again, Wade, and thanks everyone for joining.
Yeah, thanks. See y'all next week.